Hello, and welcome to 5 Minute Math. Today we are looking at the sixth grade concept of interpreting numeric data. This is 6.13a, Readiness Practice, the advanced version. If you're interested in exploring the 6.13a Readiness Practice for the intermediate or proficient versions, or the Readiness Practice resource aligned with any other standard, you can find those by using the link in the video description. So we have a stem and leaf plot here. We've got 36 different seedlings recorded, and our key tells us that we've got the decimals here. So this is our ones place, and this is going to be our tenths place. So line 2 is actually 1.2, or 1.2. So that's one way that we can think about it is 1.2, 1.5, 1.8. That's how we would read that first line. 1 and 2 tenths, 1 and 5 tenths, 1 and 8 tenths. All right, so we need to answer several questions. Range, well, that is the difference between the lowest number, so that's going to be a 1.2, and the highest number, so that's a 5, and then all the way over here is that 8. So 5.8, 5 and 8 tenths, so it's going to get us 4 and 6 tenths. It's going to be our range. Now the median height, all right, well, there are 36. So what I'm thinking here is if there are 36, there's going to be 18 on one side, 18 on the other side, right? And then my median, because that 18 is half of 36, right? So the median is going to be right between those two. Okay, so if I count up from 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So right there. And if I would count it down, I would get to 18 on that 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So just so you to see, it's right in between 3.7 and 3.8. Now that's kind of tricky because it's going to be a number in between those two. And it seems like those two numbers are consecutive, but if I add zeros, which you can with decimals, then you're good. You can make it 3.75. So 3.75 is going to be right in between that 3.7 and 3.8. So our answer to that second one is 3 and 75 hundredths. Next, the mode. We're looking for any number that shows up more than once, right? To see which one's the most. So I've got 2 5s right there. I've got 2 3s right there. 2 2s right there. Okay, so that's it. So it's tied. Let me just go ahead and put this. This is going to be 2.5, 2 and 5 tenths. I've also got a 3 and 3 tenths. And then I've also got a 4 and 2 tenths. So it is possible to have more than one mode because they all show up at least twice. If one of them showed up 3 times, then obviously that would have been the mode, but that's all we had. Next, we need the mean. Well, that means we need to add all these up and divide by how many we have. So let's do a little long division. So I added these up, and they're 132 and 4 tenths. So there are 36 numbers, and so we're going to try to find that mean. And I'm guessing it's going to be kind of close to 3.75 since that is my median. And let's see, so 36 goes into, I believe it's going to go in 3 times. Yeah, so 36 times 3 is 108, and that is going to be 24. I'm going to bring that 4 down, and so it's going to go in, let's see, 4 times? No, it's going to go more than that. Let's go 6 times. So 6 times, so 36 times 6, 1821. There we go. And so that's going to be 28. Now it says we're just going to round it to thousands place. So let's do 2 more. All right, so 36 is going to go into 280. Let's do that 7 times. So if 36 times 6 is 216, I'm just going to add a 36. That's going to get me 252. That's 36 times 7. And then that's going to be 28. And interesting, look at that. Let's bring that right there. There we go. If you see here, I just had that 280. So that means we're going to end up with a repeating. So we can stop right there. We can say 3.67, and then it's that repeating. So the repeating symbol goes over the 7, not over the 6, 7. So let's make sure we get that right there. So 3.67 is going to be repeating. That will be our answer. So let's get that in green. There we go. And then our answer is, for the last one, it's going to end up being a fraction. So what fraction of the seedlings were between 30 and 50? And so let's see, 30 and 50. So we are going to say that we are going to include the 30 and the 50. So I'm going to just kind of draw a box around them. 50 goes to right there. All right. So I need to count all of those up. I know it's going to be over 36. At least initially, I might be able to simplify. So let's see. It looks like I've got the same number on my 30 and my 40 row. So I've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. So 23 is a prime number. We can't do anything with that. So that is going to be our answer for that one. And we have answered all the questions. Problem number 1. For number 2, we have a dot plot here. We're answering some questions, range, median mode, all of that. Okay. So let's see the range. We are looking at the numbers that have a dot in front of them. So it's going to be just a 9 minus 1. We're not worried about the 10 or the 0. They're on the graph, but they do not have any dots on them. So we're not going to count them. So median doesn't tell us how many kids we had. Let's see. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so if there's 17, then watch. You can do 8 on one side, 8 on the other side, and it's going to be that one right in the middle. That's going to get your answer. And so we actually have a number. If it's odd, the median will be actually a number. So let's count up. It's going to be that ninth one counting up or down. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there we go. Our mode is going to be, our median is going to be 3. Let's put a green box around that. Now, what's funny is that's the median, but you see how it's kind of skewed over to the left. 3 is not necessarily in the middle between 1 and 9, but we had a lot of data in 1 and 2, so that's kind of pushing our median over to the left. The mode is going to be the highest one, so that's visually very easy to see. It's going to be 1 because it's got 5 dots. Now, mean, okay, so let's just add these up, and we're going to divide by 17, right? And we'll round to the thousandths place. So let's see, 1, 2, 3, 4, 5. And this is going to be 2, 4, 6. That's 3. So let's add those up. 11, that's 14. Just keep a running sum. That's 5 and 6, that's 11. And 14, it's 25. And 8 and 27, it's going to be 35. All right, so we've got 25 and 35. All right, that's going to be 60, 74. So it's 74 over, and then how many I said we had? We had 17. So let's do a little long division here. 17 into 74. And so let's try 5 is going to be a little bit too big, so let's try 4. See what that gets us. There we go. That's going to get me 68. All right, so that's going to get a remainder of 6. Add a decimal, bring that down. 60. So 4 was going to be too large. Let's do 3. So that is going to be 51. Let's do 9. We could do 5 on that next one, I think. 17 times 5. Yeah, 85. All right, 85. And let's try one more just to kind of get it to the thousandths place. Actually, we'll need 2 more because we want to round it to the thousandths place. So 17. Oh, it's almost going to be 3. That would have been perfect. It's going to be 2. So it's going to be 34. So that's going to get us a big one. 16. And so that's going to end up being 9. 17 times 9. That's going to be 153. All right, and then it's going to kind of go on forever and ever and ever, but let's round this up to the thousandths place. So we will say approximately 4.353. We'll just round the 10,000ths place. Is going to push that 2 up into a 3. And then what fraction of the students practice for 4 or less hours? Let's see how many we actually have. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. That 14 seemed a little bit too large. 9 out of our total of 17. 17 is prime, so we can't do anything with that. All right, so that is our second number, second problem. Third, we have a box plot. Students visiting a local library. Now, interesting thing about this is we don't know how many students are actually in this data set. We know the box and whiskers here. That's what these 2 lines coming off the box left to right are called sometimes. And so we could say the minimum, right, is going to be that very edge right there. First quartile, so our quartiles are going to be the edge of the boxes. So this is Q1. This is Q3. Our median here is Q2, that line. Now, it might not be the middle of the box, but it's the middle of the data. And you notice we've got this huge outlier way up here at 20, like it's really skewed over to the left. So the first quartile is going to be between 2 and 3. So let's call it about, I'm going to estimate, call it 2 1/4. Okay, 2.25. If you got close to that, you're good, because it is an estimate. The median looks like it's going to be smack dab right in the middle. We'll call that a 4.5 for my quartile 2. The third quartile looks like it's a nice 7.5. And then the maximum, see, that's really kind of skewing our data, is that 20 right up there. Now the interquartile range, right, is the difference between the Q3 and the Q1. Right, so I think it's going to be 7.5 minus that, what I consider 2.25. We need to add a 0, do a little bit of regrouping. That's going to be 5, 2, 5. So we'll call that 5.25, or at least that's our estimate, because we're still kind of making a best guess on quartile 1. And that's what we need to do with that box plot. Pretty easy to answer. If you are interested in the 6.13a readiness practice for the intermediate or proficient version, or the readiness practice resource along with any other standard, you can find those by using the link in the video description.